Hello and welcome to this series on lectures on elements of civil engineering. We are continuing with the lectures on water resources management as one part of the module under water resources. I am Professor Pradeep Loda from Civil Engineering Department, LE College Morbi. If you have questions or anything after my lecture, you could contact me on this given email address onto the screen. You can communicate. I would be more than happy to answer your questions or any queries regarding this subject so that you could perform better in the examination. Today's topic is Introduction to Weirs, barrages and check dams. In the last lecture, we have discussed various dams and dam structures, their classifications and how they function, functionality of dams. Today we are going to discuss few other structures. These are also hydraulic structures as they are also built in water, or to divert the water in the channel to create the reservoir impounding or such purposes. The purpose of these structures is to deal with water. Today we are going to discuss three new structures. First being among them is weirs, second barrages, and third is check dam. Let's see. Before that, a quick cursor through this the context of GTU syllabus that we are going through the fourth part of the fifth module under water resources. As we have seen in previous lecture, we are going to discuss today is the weirs, barrages and check dams. Again, I give you list of books as previously. I also given you the book that GTU has mentioned, this book published by Tata McGraw-Hill as a reference book for this subject by Dr. Jain and Dr. Loda, and two reference books I have given you onto the screen. You can utilize to enhance your knowledge or just to get a little bit deeper information on the subject of weirs, barrages, or say check dams. You will find some more details in these two books. No need to purchase reference book. You could purchase only textbook, but reference book you go to library, refer for time being for 10-15 minutes to get acquainted with the particular topic. Today we are going to discuss these many topics, certain definition of the structures. Then we are going to discuss weirs, barrages, especially comparison of weirs and barrages. Then we would look at check dams, their objectives, and also classification. Let's see the definition first about the weir. What is weir? It's a small overflow dam. It's a very small overflow dam used within a river channel to raise the water level for abstraction, that is withdrawal, to take the water out of the raised water, pool water, and can also be used for flow measurement and can also be used for diverting the water. So weir is a kind of multi-purpose structure which can be used for say flow measurement, that how much flow is actually taking place in a particular say laboratory channel or in actual channel. These weirs are created. This is basically a small dam kind of thing that it has on a foundation. It would have a height, and then it would be having a breadth, and water is flowing above it. I would show you sketches that how it would look like, but the major purpose or objective of construction is that we can measure the flow in actual channels. We can also, when we obstruct the flow, there would be rise in the water level upstream. So this this water which is here onto the upstream side can be diverted into channels, small channels, and that water can be taken to some purpose. So that is also a purpose, and the other purpose, that it can be abstracted directly through pumping for other purposes. Weir is also defined as hydraulic barrier over which water flows in an open channel. Open channel may be a new terminology for you. The water in pipe is, we call it in engineering as closed conduit flow. When water flows into a pipe, it's a closed conduit flow. But in open channel like river or canal, the water flows as at atmospheric pressure, and it flows because of gravity from one point to the lower point, another point. So that flow is open channel flow. So this weir is also defined as hydraulic barrier over which the water flows in an open channel. The surface over which the water flows is called the crest. This is part of the weir. If we divide the weir, then the topmost portion of the weir over which the flow is taking place or water is overflowing, that we call it as crest. There is the second statement given: the overflowing sheet overflowing sheet of water is called nappy. The water which is going above the crest and then joining the downstream, because all the water is not hauled back onto the upstream side, but it is going down, and that the water jet which is striking down onto the downstream side is nappy. We call it as nappy in the technical terms. You could see these two portion, that crest. This is a V notch. There may be many types of notches available. This is particularly for flow measurement. This V notch is used for measurement of flows. The shape is given here. If I mark it with the arrow, this is a kind of weir. The water is flowing. This is nappy. This is crest of the weir. This is a metallic sheet fitted into these two portions. You can call that the created portion, and water is held back, and the height is taken up to this, and then excess water above this height is falling down here and would be joining the downstream downside stream, or nala you can say, or channel you can say. And because of this depth availability here, we could measure that how much quantity of flow is taking place through this particular channel. Let's see onto the screen that how we could look at, we could classify the weirs. Weirs can be classified into two categories, very simple type of classification. If crest, the top portion, is very sharp, then these are called sharp-crested weir. Whereas if crest is broad, like having a breadth B, if it is very thin, or even if it is a wall having breadth, but where water is touching, overflowing over it, then what happens, that portion, if it is very sharp, then we call it as a sharp-crested weir, or otherwise we call as weirs not so sharp or broad-crested weirs. Sharp-crested weirs, a weir with a sharp upstream corner or edge such that the water jumps clear off the crest, that it is not touching or gliding, but it is coming out. So water jumps clear off the crest is a sharp-crested weir. Sharp-crested weir are classified according to the shape of the weir opening, such as rectangular weir, then triangular or V-notch weir, which we have seen previously. That shape could be a trapezoidal type of, and we could give that particular V shape as parabolic weirs also. These different shape would change the formally formula we are using for measuring the flow in the channel. So particular weir is selected depending upon the amount of flow flowing through the channel and the particular equation we are using to measure the flow in the channel. So this selection depends upon location, selection depends upon whether it is into laboratory or we are actually performing it in the field where flow needs to be measured. So weirs are particularly the selection of such out of these few types depend upon the conditions prevailing over there. Weirs which are not so sharp-crested, they are called broad-crested weirs. Sometimes they are also not sharp-crested weirs. They are mentioned in the literature. So whatever you could think that they are broad-crested weirs where water glide over. So all other weirs are classified as weirs not sharp-crested. Weirs not sharp-crested are classified according to the shape of their cross-section, such as broad-crested weir simply. If there is no abutment, then broad-crested weir only a wall is constructed. Then triangular broad-crested weir, broad-crested but it is a triangular shape, then it may be a trapezoidal even, the last one. Look at this. The water jet is touching here and then jumping out of it. The water is not gliding here onto the skin of the top crest of the weir. The touching point is this. So this is a sharp-crested thing. This is a weir and this is channel, this channel. If this does not exist, then the depth here would be less. So if we creating barrier, there would be increase in the depth of flow, depth of water here, and the excess water would be flowing down. This is nappy and here the vacuum created. We need to take care. We'll discuss if time permit more about that, how we can take care. Otherwise this kind of vacuum may destabilize the structure. Weir which we are using for the flow measurement or abstraction of water from the upstream. Here a few more images of the weir so that you could be conversant with that how weir would be. Again you look at this is the similar one which we have seen in the previous slide, but you could think about that this is here the flow taking place. Now the B is only a wall constructed, but the wall is very broad here. You look at this, the breadth here is very much from here to here, and the flow is just and with the increased depth going up and then here on this and then joining the downstream side. This is a particular shape given. It's not like sharp-crested, but water is gliding. Here depth H is created because of the height of this weir. In dam engineering we call it as a ogee shape. Generally constructed for spilling water, spillways, that water is excess water is allowed to flow downstream, and in weirs also this kind of structure can be used to measure the flow. And here this is a broad-crested with a notch provided at the end so that water is not touching the downstream side here, and the nappy is generated like in the sharp-crested, but the water jet is touching the total crest here but not damaging the downstream side of the weir. So that is the difference. So these structures are constructed in the channel, river or anywhere to measuring or abstractions of the water. How to then how the flow would be measured? That is, a flow in the channel is called discharge. Discharge means how much cubic meter of water is flowing through in a particular minute or in 1 hour, and generally it is taken as a cubic meter per second, or we call it cubic, that cubic meter per second. So cubic and cubic are two units of measuring the flow through the channel, and that flow in the channel is called discharge. discharge through a weir. So how much discharge is taking place through a weir? So this is a general equation we can think about. This is not a particular equation. This is generalized form to make you understand that how the Q, which we call as discharge, is would be equal to CLH raised to the power n. What is the these variables here? Q is flow rate of the fluid, that is water flowing through the channel. C is a constant for the structure. Different structure and different shape of the structure would be having different values here. Then L is the width of the crest. At the crest, how much is the width? L is not length of the weir, but it's the width, and H is the height of the head over height of the head of water over the crest, not from the bottom of the channel but over the crest. What is the height of the water? So that need to be taken, and this index n that varies with different structure. This is 3/2 for horizontal weir and 5/2 for V-notch weir. So this is a general representation of equation for measuring the flow through the weirs. This is a particular equation for measuring flow of the rectangular weir. You need not to worry. This is for making you understand that how flows are measured. You just look at this equation that what we have seen earlier, that H is there with indexed here 3/2. What we have seen that this was n. This 2g is also a constant. B is the breadth at the top. Earlier we have taken L, and CD is constant. 2/3 is also constant. Equation is same, but the formulation is for rectangular weir, and this equation gives us exact value of Q in cubic meter per second if we measure other parameters like this. Barrages are the second structure we are going to discuss today. We have seen weirs. Weirs were simple structures constructed across in any channel, any river, any nala, small say tributary to measure the flow. Barrages are a little bit complicated structure compared to weir. They are not complicated if we are comparing them with the weirs. Weir are very simple structures to measure the flow or abstraction. Just we are creating barrier. Here we need to think about, say, first we create a small barrier, and then what we provide gates over this barrier in abutment and in the piers. Between the piers we provide gates, so we can hold water, large quantity of water upstream, and we can also control by lifting these gates up or down that water is held back onto the upstream side, or we allow the water. That depends upon the condition. That in case of say monsoon heavy flows or floods, in case of flood we need to allow water go downstream as quickly as possible. So in that case what we do, we open gate slowly and allow the water to pass it to downstream side. But in case say towards the end of monsoon we need more water to hold back in the reservoir created by the barrage. So we keep all those gates closed and hold the water so that that water can be utilized for the crops or for drinking purpose in the month of say October, November, December, January, where water is not available through the monsoon to the crops or for any other purpose. So barrages are basically we can think as storage structures also. Like dam is for storage, also for many other purposes, as we have seen that they can be for flood mitigation, they can be for irrigation. For irrigation and water supply, they are storage structures. We store water and then supply. In case of flood, storage is there, but there is controlled output or controlled release of the water downstream side. So likewise, barrage is also a structure where the storage is created, and this storage is taken as and when we need it, we require it for the purpose we created the structure. I read it for you that a barrage is a low head diversion dam. It's a very low head diversion dam which consists of number of large gates fitted on its crest. Crest is similar to that of Weir, that can be opened or closed. Like we can pull it up and can lower it. Sometimes gates are radially, so we can lower it or make it opened or closed to control the amount of water passing through the structure, to regulate and stabilize river water elevation upstream for the use in irrigation and other purposes. This is a particular view, a very typical view I have taken just from Google to make you aware with that how it differs from the weirs, or for that matter from dams. Dams are generally high, very high, and then on top of that, say above 50 meter or 100 meter, we provide gate. But here after 2-3 meter, this base is created and then gates are fitted. This is a kind of a structure to control, handle, or say operate the gates, to lower them or to drag them up so that the gates are open and closed. And these are the channels where the excess water is getting released to downstream side. So this is a particular view of a particular typical barrage. Few salient features about the barrages. Let's look at these points. The gates are constructed between piers. I have told this in I have already spoken about piers, but I show you that where the piers and what is the abutment. If we look at this valley and channel, then all these where the gates are fitted in, this point and this point, this point and this point, then these structures standing tall, and what is, there are gates fitted in. So all these are weirs here, 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 and at the end there would be abutment. This is the rock where the finally load is carried into the sides of the valley, and these weirs would carry the load to the bottom foundation. Between the piers, which are responsible for supporting the water load of the reservoir created, the key difference between barrage and dam is that dam is built for water storage in a reservoir which raises the level of water significantly very high. A barrage is built for diverting water and raises the water level only a few meters. Few meters here could be 10 meters, 15 meters approximately. So that is big difference, that gates are lowered to raise the water and that water is diverted. Mostly barrages are constructed for diverting the water into canals, mostly for irrigation purposes. You will find these barrages built. We have one on Sabarmati, Vasna barrage. If you have seen Sabarmati, this barrage downstream of the riverfront, if we go, then it is holding the water also of the riverfront. The whole junk, if we open, then the water of the riverfront also gets passed through to the downstream of the Sabarmati. And at Vasna barrage, onto the right, there is a canal taking off towards the Sanand region. The basic difference between now we are comparing this weirs and barrages. We are comparing these two structures, that which one is suitable where, and how the cost comparisons we can make about these two things. So basic difference between weir and barrages is of gates, that is the flow in barrage is regulated by gates, but the crest height in the case of weirs, only the crest height is there. Beyond that we can't manage, we can't control the flow. Barrages are expensive than weirs, that they are very expensive. They are not simple structure. We need technology. We need technology to lift the gate, to lower the gate. because over the years there would be problem of rusting, clogging, and silting. So these all mechanized part need to be maintained. And if we are not controlling it automatically, if it is not controlled through a control room, then if a person is going, he is going to open this every day or every alternate day to allow water to pass through or to hold it on into the reservoir. So many other parts are getting involved in the construction of the barrage. So decisions should be taken appropriately, that where we are requiring a barrage and where we are. Weirs and barrages are constructed mostly in plain areas, both in plain areas. The crest level in the barrage, top of solid obstruction, is kept at a low level. It's not that high. It's only few meters. Few meters means only 2-3 meters or 4 meters like that, or 5 meters. And beyond that, the height or reservoir is created by closing the gates. So that is what is the basic comparison of weir and barrages. During flooding situation, gates of the barrage are raised to clear the high flood level. As a result, there is less silting and providing better regulation and control than the weir. In weir, silt will get deposited upstream, but in case of barrage, when we open, the water gushes out of while opening the gate, water comes out, and it takes also the sedimented deposited sediment along with it because of the high velocity when we are opening the gates. So that is benefit that we could regulate the silting in the barrage, but silting in weirs is difficult. We need mechanical devices to eject the deposited silt upstream. Now this is third and last type of structure, hydraulic structure, we are going to discuss, apart from what we discussed in the last lecture. In last lecture we have seen various types of dams, in which we concentrated, mainly focused on gravity dams and earthen dams. Today we have seen weirs and barrages. Apart from that, we are going to also discuss check dams. The basic difference between dam and check dam, why the two names are given. Say first, they are called dams only, and why these dams are called check dams. This check particularly word is used for check dams because it curtails something, it arrests something, it stops something, it checks. It stops. What is that? The soil erosion from the area where they are getting constructed. They stop or they check soil erosion. That is one of the important drive of the Indian government or the central government and the state government, that we maintain the fertility levels of our soil, and for that we need to check, we need to stop the soil erosion and maintain the fertility. So check dams become popular in last 3-4 decades, and they are being constructed not only in our state Gujarat but all over country, and many other countries such practices are being maintained. That check dams are constructed to maintain the soil fertility, to reduce or lower the soil erosion from the areas which are very prone to erosion. Basically, erosion takes place because of a few reasons. This is particularly for water erosion, where steeper slopes, the topography or the topography is steeper, having slopes say 3%, 4%, 5%. Then what happens that the velocity of flows becoming very high, and it carries the sediment along with it in suspension, and that suspended particle will get deposited in particular areas, reducing the fertility of the areas from where they were detached from, and creating nuisance problem where they are getting deposited. So this is a two-way problem we are checking through this check dams. One more objective of creation of check dam is that when we create barrier, velocities are getting reduced of the flows. Because of the reduced velocity, water getting more time to get percolated into the soil mass. So water which is getting upheld upstream of the check dam start percolating into the soil mass, thereby recharging the area, recharging the soil mass, and water going down into the soil, and we call it recharge of groundwater, so ultimately augmenting the groundwater. So that is another benefit, or you can say the byproduct of the construction of check dam. So apart from check dam is also useful in augmenting the groundwater recharge in the areas. So this is scheme you would find in your area, in your village, in your taluka, that the people are constructing the check dams over very small streams where flows are only few cusecs, to large streams where flows are, say, in thousands of cusecs. But these are helpful in for many other purposes. So let's see that how the check dams are beneficial for us. I read it out for you that check dams are also called as in-stream storage structures. Basically, weirs are also in-stream, and mostly they are not on diverted routes, but they are in-stream storage structure. But check dams are definitely on stream. A check dam is a small dam designed mainly to decrease flow velocity and control soil erosion. As I have spoken on this, these are two things that it check the soil erosion. It also helps in groundwater recharge. That is the byproduct. When we are checking arresting soil erosion, then velocities are getting reduced, and then reduced velocity augment the groundwater through recharge. The broad objectives of check dams to provide drinking water facilities in the villages along both sides of the river after monsoon period. Check dam is dam where heights are, say, 2 meter, 3 meter, 5 meter, up to 10 meter, and they are constructed with the help of local available material. Mostly technical know-how is not that much rigorous as in the earthen dam or in the gravity dam. Here the local knowledge of creating barrier, local knowledge for creation of the barrier and holding water is taken advantage of. The people, the elderly people which are very expert in the area, they suggest ways to hold the water back, to arrest the government provide funds, and with the help of such fundings and some participatory schemes, these barriers are constructed. Now after construction, water is available upstream of it for few months. They can't hold water for full year, but for few months, like say we are storing water in the month of September, October in the check dam, so that water can be applied, say, as a irrigation water to crop once at the end of the season in monsoon season for creep crops, or remaining water can be taken out, can be withdrawn for giving the water supplies in the nearby village. If a check dam is large enough to supply the water for, say, a village of 500 to 1000 population, or say 5000 population, then more check dams can also be constructed, and the advantage of supplying water during a few more months can be taken. The second broad objective is groundwater recharge. Third is to provide incidental irrigation. That is not purpose of irrigation, but incidental, because if rainfall is not uniform as per the requirement of crop, then we can use this water during the late kharif and rabi season by storing water at the end of monsoon, mainly through lifting devices, to divert water from perennial, semi-perennial streams in a hilly area for irrigation purpose. Other uses by villages like bathing, washing, fishing, recreation, etc., depending on location and potentiality of a particular point, particular check dam. Salient features of check dam. The check dam should be capable of safely releasing the anticipated design flood without affecting the safety of a structure, with minimum efflux in the upstream. This I need to speak about, that efflux created because of the creation of dam. In case of dams, the submergence is because of efflux created. That is the height raised because of the dam body, the wall we create. So that create that rise in the water above the normal river channel water level. So that additional height gained by the water course because of this structure. So in case of check dams, the efflux should be minimum. It should not take much of the land, because these are created in private farms, private areas. Areas or land not belonging to the government or say local bodies. So in that case, what is important is that the efflux should be minimum. There should be very less submergence, and also in case if there is more rain, then this structure which is built across a particular small channel maybe, but it should allow that excess water to flow to the downstream side. Otherwise what would happen, that this flow would cause failure of this structure, and that stored water would also join the rainwater and would cause damages to the crops downstream, or maybe if there are hutments and like these things, then there would be problem to these structures also. So care should be taken. It should not be created randomly without little experience, without knowledge of experienced person of the area or the technical know-how from the engineers. At least few standard procedures should be followed while creating check dams. Water can be stored in such ponds or reservoirs towards the end of monsoon season based on the type of stream or nala where the structure is proposed to be constructed. The check dams may be divided into three categories. So we are looking now the types or categories of the check dams. This is the first type of the check dams, type 1 we call it, very simple structure, and they are having height of 2 meters, and they can be constructed across a small tributaries, very small, nala kind of, say secondary or tertiary kind of drainage system. In hydrology, if very small drainage, then they are primary drainage system, they are called primary drainage system. So if very small nala, then these can be used, water can be held in such streams, small streams, by creating small check dam and type 1 drainage channel within the banks and in hilly streams. These storage scheme will be low cost, very low cost structures, and will be primarily used for the purpose of irrigation through lift, that is through pump, and using pump and lifting the water. Recharging of groundwater is possible, providing drinking water facility to just one nearby village. Now let us look at the second type of the check dam, type 2. These check dams are built in deltaic rivers drainage channel. These structures will be constructed on deltaic rivers, nala drainage channels with alluvial bed, and will be primarily used for providing irrigation facility by lifting water during later part of the monsoon and rabi season. Means the storage is a little longer compared to type 1, and these can also be built on alluvial soils where river is getting higher orders compared to the type 1. This is third and last type of check dams. These check dams across major rivers, streams having higher width and use flood water discharge. These check dams are constructed. Earlier two are smaller comparatively, but these are, we need to take precaution while constructing type 3, and proper sanctions and permissions should be taken from the irrigation department, and areas in which they are being constructed, permission should be taken from the local bodies, local controlling authorities of that particular area. Without the permission of those, these are not built. Even if there is a public construction of such thing, proper permissions are needed. These structures can be used for the purpose of drinking water facility to nearby villages. We can supply water to nearby villages almost throughout the year, because the storage is more in such kind of type 3 check dams, and they are major structure in terms of check dams. Irrigation facility we can create. These are sustainable irrigation facility. In the earlier cases, those were only say incidental. Here we could create irrigation facility which are sustainable, which can sustain the crop for longer time period. If we are thinking of the kharif crop, that is the monsoon season crop or the winter crop, the water is stored here because check dam is large and the storage capacity is large. Water can be supplied to nearby villages from here to those. So they are sustainable structures compared to type 2 and type 1. Useful for meeting industrial demand. Water can be supplied from these to industries also, and water can be supplied during lean periods also, that is November to May as mentioned in this slide. This site should be selected after detailed survey. Here mention of this in earlier 2 check dams it was not there, that site selection should be proper. It should not be say created at any point. We need to have a good site where structure we assume that would be standing for a few years, because expenditure on such a project is going to be quite good, maybe touching to few crores of rupees in creation of such structures. So surveys and investigations, these structures will be constructed, operated and maintained by government departments. So that is big thing here. They cannot be privately owned if such a big structure is there. So there would be consent, and operation and maintenance also should be done by the government department, who is controlling the area and responsible for supply of water, or say supply of water for irrigation, or say for power, if power generation, water is supplying to power generation or to the industry, then proper coordination should be done there. In this particular lecture we have seen 3 type of structure. One is the weirs, second barrages, third check dams. These 3 are hydraulic structures. The purposes of all 3 are different, and that's why the name are given differently. They are created in channel or nala or in stream or in drainage, but they are created differently. They are created with different technical know-how, and they are also serving a different purpose. So all 3 structure mostly having similar height sometimes, like check dam is having say 10 to 15 meter or 10 to 15 meter. A weir might be having height say 5 meter to 7 meter like check dam, but the purpose is different. That weir is only for say first objective is to measure the flow. If that is not for, then sometimes to abstract a particular purpose, and it's a permanent structure. Whereas check dam having same height, but there won't be much flux upstream, and it is constructed mostly for arresting the soil erosion. That is the objective kept in mind. While constructing weir, we don't keep that objective in mind. So areas, locations, location specific, objective, what is the objective. So all these situation influence. As far as the first year students are concerned, all these structures may be requiring expertise, not only of say civil engineering students. I am professor of civil engineering, I teach this subject, but many other components are there which need to be designed or need to be utilized. Say power need to be supplied for withdrawing, or say setting up of the machinery in type 3 type of check dams require expertise of electrical engineering students. So point is that how we could make these evolving ideas of managing water in better way with the help of interdisciplinary approaches. So all what I say is that if all disciplines, engineers from all disciplines are acting and putting up their knowledge in creation of such structures, then we could evolve with better and better structures. That's what I have to say about this. Thank you.